Hello, this is going to be another part of my analysis of various flights around the world and how it looks like the data that airlines post correlate with the distances that I would expect to calculate on a spherical Earth, confirmed using the Haversine function to calculate the distance between two geocoordinates. I've already made a video that showed the 10 longest flights, and I'll probably put a card right about here for you so you can watch that video. And I also made a spreadsheet available, which I'll probably put in the comments below again in this one. But when I was doing this, I wanted to be able to find a wide range of flights available, preferably flights from several cities within several countries within each continent to several cities within several other countries within other continents, and to essentially have a mix of flights around the world totaling, I was hoping for at least a few hundred that would be representative of a few flights within each continent to each other continent in a bit of a spiderweb sort of pattern. And what I ended up finding was I found data.world, and they have posted a link to on time performance 2017_1.csv. And after quite a bit of investigation, I found that it led to data that came from transstatsbts.gov. It leads to an error page, but I was able to go to, and you can do this yourself, you can go to aviation. Somewhere on this site you can go and re-download the data for January 2017. And this site is free to use. You don't have to create an account like I created an account for this site. In this spreadsheet, there's 450,000 flights. And what I did, just to make sure that Google Sheets didn't throw up on me, I trimmed it down to, I think it was a couple of thousand. And so this one is an abbreviated on-time performance of that other one. So what's really interesting about this spreadsheet is it sorts by the flight. And so I've got 15 flights from Charlotte, North Carolina to Phoenix, Arizona. It's got some interesting stats like when it departed, how many minutes it was on the runway taxiing out, when the airplane was airborne, when it landed at the destination, etc. There's a couple of fields in this spreadsheet that I was really interested in. It was based on the information that I previously used in my last video, but I reworked it slightly to make some of these calculations a little bit easier and to support even more evidence that I am going to present in another video. This is going to be kind of a two-part summation of what I found, and I think after that I'll probably end up dropping this whole flight business and move on to other topics. But for this one, this is the information that I was interested in. This is the distance between the two airports, which were derived by the distance column in this spreadsheet. These two are the names of the origin and destination airports, which came from origin city name and destination city name. So these two columns ended up becoming these. That spreadsheet did not have the geo coordinates that I use in my calculations, so I had to go and find a different spreadsheet. This spreadsheet contains a list of all of the airports, and there's one column. The IATA code column contains 3-letter codes for a given airport. So this line here would be the code for LAX, and so I would match the appropriate LAX column here for origin, or in this case maybe possibly the LAX code in the destination column. So I would match either this one or this one with this entry in the airport's CSV file, and then from there I could go and pull the latitude and longitude for that airport. So I wrote a Perl script to load this one and to hash out all of these codes along with our geo coordinates. And then I loaded this one, and as I was parsing it, I did a couple of things. So the first thing I did was to match the origin airport code with the entry from this source to get the geo coordinates. And then I did likewise for the destination as well. And these values ended up feeding these columns in this spreadsheet that I was working on, these columns. This is the total flight time in seconds, and I only found a single distance between the two airports given in this spreadsheet. And the reason why I have it duplicated here, I will explain in my next video, but this is just a duplicate of this column for this section over here. The main thing about this column, the flight time, because this spreadsheet contains over 400,000 flights, some of them are duplicated. So for, I guess, the month of January of 2017, American Airlines had what appears to be 13 flights between Florida and Charlotte, or Fort Lauderdale. So what I did was I went to the airtime column. So this is the number of minutes in flight. And so that's going to be basically going to be wheels on minus wheels off, plus whatever time zone difference there is between the two airports. And that essentially works out to be the airtime in minutes. So I take the average of all of these flights for this route, and that is what I put in this column here. I take the minutes and I multiply by 60 to give me a total number of seconds. So this column represents an average of all of the flights within that particular route converted to seconds. The distance between the two airports that were given are in miles. They're not in nautical miles, so I had to factor that into account. I've already shown the calculations that I was using here. So all of these calculations are to calculate a distance along the surface of a sphere using the Haversine function, and that gives me the globe Earth distance, which is going to be in miles. I calculated the flight speed based on a number of columns. And again, I'm going to talk about the difference between these two columns in my next video. But to quickly summarize in this one, I'm tracking flights through the Flight Aware website. And when I go and get the data from this, the traveled distance is not exactly the same as the posted distance. It's off by a little bit, so I'm taking that extra little distance into account to generate my speed difference. And then I convert my speed in miles into a kilometer-based speed difference. So instead of miles per hour difference, it's a kilometer per hour difference. And then I do a similar calculation for the difference in distance between my computed distance in miles versus their provided distance in miles. And then I take that number and I convert it to kilometers. So just for fun, I decided to calculate the average flight ground speed for all the flights, which works out to 814 kilometers per hour. And then I also went and found the minimum value in this kilometer difference column and the maximum. And I'll get to why this is so high in just a second. I also did something similar for calculating what the difference would be on a flat Earth. And so I based this on the standard AE map that most flat Earthers tend to use, placing the North Pole at the center of the map, the longitude being the angle around the flat Earth with the North Pole being the axis of rotation. Latitude would be essentially the distance to that location from the North Pole. And that ultimately gives me a distance between those two airports if we lived on a flat Earth. And then I go and calculate the same kind of differences both in speed and difference in distance. Again, I decided to do a few things. I took the average flat Earth ground speed for all the flights. It's not just over 800 kilometers per hour on the globe, but it's actually almost 900 kilometers per hour. And the min-max difference is subtly different. Most of the differences are positive. There's only a few that are negative, and the smallest difference in the negative side of things is -4 kilometers. The greatest kilometer difference is over 2,200 kilometers. Once I had the over 4,000 unique US flights for January of 2017, I then had something that I thought was reasonably good enough to calculate and to compare. And so what I did was I created a scatter plot for the globe Earth using the distance that the airlines provided on the x-axis. So each one of these would fit along the x-axis, and on the y-axis I used the difference in kilometers. So I used this column here. That was on the first graph, and this is what the graph looks like. You can see that I had a few outliers, and that could be due to a number of reasons. One of them was some of the data was not particularly clean, and the flight time ended up calculating to 0. So I substituted a flight time of 60 seconds. And in those cases, there were two airports that were fairly close together. So in this case, we're talking Sacramento to Reno with a posted distance between the two airports of 113 miles. And so what I ended up doing was I just set it to a minimum of 60 seconds for the flight. That could be one of the explanations for the outliers. The other could be, I haven't chased this part down, I might have had a bit of a problem looking up certain airports and matching the relevant record from here with the relevant record from here. So there are some reasons I can think of why those outliers would exist. So I'll tend to discount those. I'll just ignore those for now, and I'll just look at the rest of them. So as you can see, most of them are fairly close to the 0 mark, except for these outliers. I'm going to go -20 to 20. So here you can see that with the exception of those few outliers that are really up high here, just about all of the other flights with a range of anywhere between 0 and 5,000 miles between the two airports, the difference between my calculated difference between those two airports using the Haversine function with the posted difference that the airline gave are all within something like -13 or 14 kilometers to under 10. So we have an overall spread of about 25 kilometers difference between all of the airports for all of the flights in the US for the month of January 2017. Let's see what the graph would look like for the flat Earth. Here, there's a couple of things that we can notice. One, as I've already shown here, the minimum is -4 versus the minimum over here being -14. Most of the differences between the two, calculating distances for a flat Earth versus calculating the distance for a globe Earth, most of those differences are positive, not negative. And what's even more telling is that the greater the distance between the two airports, the greater the distance becomes, and it's almost linear. So in other words, it's almost like a sloping line correlating a difference in the two airports converted to kilometers versus the distance itself. Given the fact that some of these differences stretch as high as 2,000 kilometers, and I would have to go and find out which one this one would be. It looks like it's going to be this row here, Guam to Honolulu. So if I examine this data a little bit more carefully, I might just end up finding a few flights that are from the southern hemisphere or possibly from Asia to the US, but this database is US carriers. That's going to be it for this video. There is one more coming up, but this to me is yet even more concrete proof that the Earth is a globe and not a flat Earth. All the data related to airlines say that the Earth is a globe. So if you like this video, I would certainly appreciate the subscribe, the thumbs up, comment below, all that other good stuff. Don't forget to hit the notification bell. And that's going to be it for this part. And I'm going to see you again very shortly in another video after this one. Bye for now.